Hi guys, I am Praneeth. I'm a MuleSoft integration consultant. Today we shall discuss how to log and notify response time or processing time of each message processor present in each Mule flow using Mule server notifications. Before we directly going into the topic, we shall get into context of API performance. We all know that performance is a key factor to consider if an API is implemented and delivered efficiently and optimally. In any project lifecycle, right before the production deployment or go live, NFR testing is a mandatory phase. That is, non-functional requirements testing is a mandatory phase, where performance testing is also part of it. During design of any application or an API, we define SLAs, that is service level agreements with client systems on response time of an application or API, which is which when breached is considered as an NFR defect. So in the performance context, response time is a base metric to define the performance of an API. This is all very generic with respect to any kind of project. So now we shall go into the topic called Mule server notifications. This is something like a mechanism of accessing the Mule server to get notified with the changes that occur on the Mule server. Today, keeping the context of abiding to response times defined for an API, I would like to explain a feature in Mule where we can log or notify the response times of each message processor in any Mule flow using the Mule server notifications. By default, these notifications are disabled. Reason being, this kind of logging and notifications have impact on response time of the overall API, since every message going in and coming out of Mule server has to be logged and notified. Let us now go into the use case. As a developer, I want to debug across all Mule flows in my application and log the response times of each and every message processor. Whenever we talk about an API, we know that it comprises of message processors, API invocations, etc. etc. API invocations can be of different types, like invoking external or third-party APIs, or invoking process API from experience API, system API from process API, etc. To be clear, developer has no control over response times of external APIs or third-party APIs, since they are being built by some third-party vendors. So they had to abide to their SLAs actually, and so we don't have any control over the response times of such APIs. And since process API and system API are anyways internal, we could handle their response times independently. So now message processor optimizations are only the way to optimize the response time of our overall API. In this video, we'll see how to log response times or processing times of each message processor in MuleForce, and we could see the response times of each message processor and act accordingly. We shall now move on to implementation of logging the response times of each message processor in a Mule flow. Firstly, we need to create a Mule project. Then soon after creating a Mule project, we'll need to create a class called Mule Component Process Listener in source main Java folder. This is a class actually implements message processor notification listener interface of Java, where we will be using on notification method to log and notify the information related to message processor. Then create beans.xml file in source main resources folder. This is a file where we register our beans which we'll be using in the project. As I said, we need to create a bean specifying the class which is created in step 2, that is Mule Component Process Listener. Then after creating a bean in beans.xml file, this beans.xml file has to be registered in the Spring configuration, that is the main XML file where our Mule flow exists. Then we have to specify notifications we want to receive using notification element and have to register the listener class being using notification listener. This shown here. Now I'm just giving you the overview of all the implementation steps. When we get on to AnyPoint Studio, I will explain which configuration should be placed, where and why. Then for all these things, we need some specific dependencies to be added to the pom.xml file. So we need to update the pom.xml with respect to all those dependencies. Then we have to build a mule flow now with the required message process. This is the mule flow I've created for our use case. Let me first explain my flow, what is in there and what it actually does. This flow basically, when invoked by a client, loads a JSON file into the payload from class path using the read URL function of data view, then logs the payload, then transforms it into a specific format using small Java class invoked using invoke static component, and then responding back to the client with the transformed JSON. This is actual functionality of my flow. But with respect to our topic today, we shall now see how many message processes are present in the Mule flow. One is loggers, then the transform message components, flow reference, and invoke static components are the message process in our flow. As I earlier explained in the presentation, we shall see what should be in Java class, beans.xml, and their respective configurations. So this is the Java class which I was mentioning about in the presentation. So this is created under source main Java folder. Okay. So this class actually implements message processor notification listener interface of Java. So in this we'll be using on notification method in which we'll be logging component details with their execution time. Okay. So next thing is beans.xml which is created under source main resources. So the class created here, I mean the mule component process listener, this class has to be created as a bean in this bean class, bean.xml. Okay. Now this beans.xml has to be registered in the Spring context, that is in a in our XML file. So that registration will be done in this way. Spring configuration, we are giving a name to it, and file which has to be referred is beans.xml. Then here is our actual notifications logic. So we want to notify or log information related to message processors. So that is mentioned here. Okay. So what kind of notifications and the listener, what kind of listener we are using is referred in this notification listener reference. So if you observe, this message processor notifications is what we mentioned it in beans.xml, and this name refers to the class mule component process listener. So this is how everything is interlinked. So whenever any event or action that happens on the mule server, this mule process notification listener gets invoked and it logs all this information which we configure here. So let me run the API and show you. Now I see the app up and running. Let me trigger. So now if you see the message process and its respective information with along with the response time it took for message processing is logged here. So this is for Java invoke static, and this is for logger, this is for flow reference, and this is for transform message. So this is how we can log the response times of each component and debug in during our performance testing phases, so that we can figure out which component or which processor took how much amount of time, and accordingly we can optimize our code to meet the best SLA. So the code base and all, I'll be uploading it to GitHub, and I'll share you the link in the description. Thank you.